Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we are going to do a numerical which is different than the numericals that we have did earlier. And in this case, a reaction is given and we have to predict what would be the anode and what would be the cathode. And eventually we have to calculate what would be the delta G value. So let us see what is the numerical. So on the screen there is a question which is present on how to calculate the E naught cell as well as delta G naught and equilibrium constant for the given reaction. This is the reaction that is been not been said or not been there in 12th, but it was there in 11th standards redox reaction. So in this case, the E naught of Cu plus, that is been converted into Cu, the value is 0.52 volt, while that of the E naught of Cu plus and Cu, which is been converted into Cu2 plus, is been given as 0.16 volt. So because of help of this, we have to calculate what would be the E naught cell. But to predict the E naught cell, we should know what is anode and what is cathode. So now in this case, we could predict the electrode, which is anode and cathode, by knowing that this reaction is showing a redox reaction, but in this case, which is acting as anode, let us see. So the reaction that is they have provided to us is Cu plus, that is been converting into Cu2 plus Cu, which is present in the solid form, and the others are present in aqueous form. So in this case, if I observe this Cu2 plus, sorry, this Cu plus is been converted into Cu2 plus. So the oxidation number of Cu plus in this case is +1, but in this case it is +2, means the oxidation number is been increasing. And this will only happen if the electrons are being lost by Cu plus ions. So therefore, in this case, because there is loss of electron, so therefore the reaction is basically an oxidation process. When we talk about when this Cu2 plus, which is of 2 moles, that's why it is been giving us a copper in a solid form. So suppose if this Cu plus is been converting into Cu, in this case the oxidation state of Cu plus is been converted into oxidation state of 0. So this is only possible if Cu2 plus will accept electron or will gain electron so as to lose the positive charge and to acquire a 0 charge on its atom. So in this case there is gain of electron, and hence this is a reduction process. And now we could easily predict that which one is anode and which one is cathode. So in this case, as they have given us or provided us a question, in this case Cu plus is converting into Cu. So in this case, which one Cu plus is converting into Cu? So therefore the E naught of Cu plus, which is converting into Cu, is basically showing a reduction process, and hence this is said to be a cathode. While when we talk about the another one in which Cu plus is being converted into Cu2 plus, so in this case Cu plus is being converted into Cu2 plus, so the answer is 0.16 volt. So therefore I could say that the E naught of, that is Cu plus comma Cu2 plus, in this case let me tell you the comma, or let me give you an idea that this comma is because the two are in aqueous form or in an ionic form but are of different oxidation state. That's the reason the comma is been added here, while in this case a vertical line is been included between two, because this Cu2 plus is in aqueous form while this Cu which is in solid form, so they have physical difference, or they have difference in their physical state, so therefore the vertical line has been presented between these two. So this will be showing, as we know, that oxidation. So this will be nothing but the anode. So now it is very much easy to calculate. So let us see what would be the value of E naught cell. So the value of E naught cell will be E naught of cathode minus E naught of anode. So in this case, the cathode was nothing but Cu plus and Cu. So E naught of Cu plus Cu minus E naught of Cu plus which has been converted into Cu2 plus. So therefore this will be E naught of Cu plus and Cu2 plus. So the value of these two are being given to us. So let us substitute the value. We have the value of Cu plus to Cu as 0.52, while that of Cu plus, which has been converted into Cu2 plus, we have the value of 0.16 volt. So minus 0.16 volt. So let us see what is the answer that we could get for E naught cell. So we have got a value of 0.36 volt. So this is how we have calculated the value of E naught cell. So because of help of this, we could easily calculate what would be the value of that is delta G naught. So we have a formula that is delta G naught is equals to minus NF of E naught cell. So in this case, let us calculate or let us see what would be the value of N. So we know initially that during the process of oxidation, this Cu plus is converting into Cu2 plus. So this is showing an oxidation by losing one electron. So the number of electron that has been lost during oxidation, or I could say for in a half cell reaction, is 1. While if we observe that Cu2 plus is been converting into Cu, which has an oxidation number of 0. So this Cu plus will accept 1 electron, then only it will be converted into Cu. So in this half reaction also, the number of electron that has been accepted is 1. So the number of electron lost and the number of electron gained in this case is 1. So therefore I could write the value of N as 1. Into we know that what is Faraday constant, that is it has a value of 96500 coulomb per mole. Into E naught cell. E naught cell, the value that we have calculated recently, it was found to be 0.36 volt. So now let us see what is the overall answer that we could get. So we have got a value of 34740 joules, but this is present in minus, so I could write it as minus 3470 joules. This thing can be converted into kilojoules as minus 34.740 kilojoules. So this is how we have calculated the value of delta G naught, that is the standard Gibbs free energy change. But this is not the one that we have to find out ultimately. We have to calculate what would be the equilibrium constant. So let us see what would be the equilibrium constant, but equilibrium constant has a relation with E naught cell also. So let us see how can we calculate that one. We know that at equilibrium E cell is 0. So therefore the overall value or the overall formula for E naught cell will be, I will write it in this way, that is at equilibrium E cell will be considered as 0. Therefore E naught cell will be equals to 0.0592 divided by n log to the base 10 of K, that is equilibrium constant. So in this case we have recently calculated that the value of n is found to be 1. So therefore 0.0592 divided by 1 into log of K. But recently we have also calculated the value of E naught cell, which was found to be 0.36 volt. So therefore we could substitute here 0.36 volt, and let us see what is the value of log of K. So therefore the log of K value will be equals to 0.36 divided by 0.0592. So let us see what is the value that we could get. So we have got a value of 6.081. So this is the value of log of k, or the log to the base 10 of equilibrium constant. But we have to calculate the value of k, so we could write this thing as, so friends, recently we have calculated the value of log k as, log k was found to be 6.081. So therefore we could calculate the value of k as antilog of 6.081, and let us see what is the answer that we could get. We have got a value of 1205035.94. This could be written in the value of, I could write it in this way, 1, 2, 3, 4, 5, 6. So I could write it in 1.205 into 10 raised to 6. So this is also that I could represent the value of the equilibrium constant. So this is how we have calculated the value of equilibrium constant by taking the help of the E0 cell, and also we have calculated the Gibbs free energy change, that is standard Gibbs free energy change, that was I am talking about. And yes, it was so much easy. I hope you will try to do this kind of numericals and will solve it in a very easy way. So thank you for watching this video, and please share this video with your friends, and yes, don't forget to subscribe Ekeeda channel. Thank you so much.